Using the circuit shown, figure 1.1 is there. The student measured the potential V1 across R1 and the current I1 in the circuit. Figure 1.2 and 1.3 shows the voltmeter and ammeter scales. Write down the reading on the scale shown on the scale figure. So what is the voltage reading? The value of the voltage
1.8.
So value of the voltage reading, it's 1.8. And what about the current reading? That's 1.8 volts. Because
0.38.
yeah, each is here in voltmeter, each is representing 0.2. So as each is representing 0.2, that's why it is 1.8. Then the second one, that's 0.38 amperes. Calculate the resistance of Ra using the equation R1 is equals to V1 divided by I1. So what will be the resistance when the voltage is 1.8 and the current is 0.38?
4.7.
So when you divide the two values, the answer will be 4.7. 4.74, better right answer in three significant figure. 2 is also right, 2 to 3 significant figure. So 4.74 is the right answer, or 4.7 you can write as well. A student connects the resistor RB in series to RA. So what he did, student connect another resistor RB and he measured the voltage across the two resistors and the total current, a combined current. And the voltage was 1.8 and the current is 1.19. Calculate the resistance of R2. What will be the value for R2? 9.47 ohms. For paper 6, you don't have to memorize or learn any formula. Just use the formula given in the question to find the answer. The student connect the third resistor RC in series with RA and RB, and she measured the potential V3 across the three resistor and the current in the circuit. They calculate the resistance R3, RA plus RB, the combined resistance. So voltage 3, the third voltage V3 divided by 0.13. What is the resistance value for R3? 13.1. Your answer should be in three significant figure. If you write 13.07, that's four significant figures. So you should round it off to three significant figure. As it is 13.076, so it will be 13.1 ohm. On the figure, draw a line for the needle on ammeter to show the reading 0.13. How you'll show 0.13? You can use a screen annotation to show the pointer. You have to show 0.13. How you represent 0.13? So when you draw,
not great, but it's the best I could.
okay, yeah, that's right. Basically, this is a position of the pointer, and that's to the 0.13. You will show the pointer reading. That's right. Thank you. Then student suggested that R3 is equals to 3R1. Means the value of R3 is equals to 3 times the R1. What was the value of R1 when we work out the first time? The value of R1 when V1 divided by I1, that was 4.7. 4.74 or 4.7. So R1 was 4. R1 is 4.7. And what is the value of R3 when we calculate it? That is 13.1. So what students suggest? Students suggest that the value of the R3 is 3 times the R1. So 3 times the R1, if I multiply 3 with R1 value, which is 4.74. 3 into 4.74, what is the answer? That is coming out 14.2. So state whether, what we have to do, state whether the results agreed with the suggestion. So the value of the R3, the practical value of the R3 is 13.1. But when 3 multiplied by R1, 3 multiplied by 4.74, what is the value? The value is coming out 14.22 or 14.2, three significant figure. So are the values equal? Are the values same? Like practical value of the R3 is 13.1 and theoretical value, the student suggestion is that the R3 should be 14.2. So are the two values equal? So statement, no, they are not equal, and justification, you can use the value, you can use the number like within limit of experimental accuracy, two values are not equal to each other. There's also another way when you're comparing, it's a 1 mark, but there's also another way to compare the two values, and that is called a percentage difference. So whenever we are comparing the two values, we compare the percentage difference. Percentage difference is maximum minus minimum divided by mean into 100. So if we compare the two values and calculate the percentage difference, if the percentage difference is less than or equal to 10%, we will say the two values are equal. But if the percentage difference is more than 10%, then we will say two values are unequal. This is also a way to calculate or to identify whether two values are equal or not. So when, according to student suggestion, R3 is 3 multiplied by R1. So 3 multiplied by R1 means 3 multiplied by 4.72. That is equals to 12. 3 multiplied by 14.22. So this was 14.22. And the student value when calculated, it is 13.2. So how we can work out this? We can compare the percentage difference. Percentage difference is the maximum value, which is 14.2, minus minimum value, which is 13.2 or 13.1, I guess, 13.1, divided by mean. What is the mean of these two values? 14.2 plus 13.1 divided by 2. What is the average value of these two? 13.7 or 13.65 into 100. So when 14.2 minus 13.1, that is 1.1. So 1.1 divided by 13.65 into 100. So when you calculate, you will get 8%. So if the value is 8%, it means it is less than 10. So if the value is less than 10, what it shows? It shows that the two values are equal. So the practical way, even that's the point here, that look, when I look at 13.2 and when I look at the value 14 or 13.1 and I look at 14.2, the two values does not look same. But practically, because when you're doing an experiment, there are sources of error, so you will not get the exact numbers, exact answer. So if you are not getting the exact number or exact answer, you have to work out this percentage difference. So percent in this example, by looking at the number, it appeared that the numbers are not same. But when we calculate the percentage difference, it was 8%, which is less than 10. So what we will write statement here, we will write yes and justification within limit of experimental accuracy. The two values are equal because the percentage difference is less than 10. Is it clear? So whenever in exam you are comparing the two values, what you will do, you will calculate the percentage difference instead of directly saying the answer by looking at the number. Like according to practical, R3 is 13.2. But when we are calculating by the values, as the student suggests, R3 is 3 times R1, so that is equals to 14.2. So if we want to check whether the two values are equal or closer, so we always calculate the percentage difference, which is maximum value minus minimum value divided by mean or average into 100. Then another student suggested that three resistors RA, RB and RC have the same value of resistance. Explain how could you use the circuit in figure 1.1 to check this suggestion. Another student suggests that RA, RB and RC all have the same value. So in this circuit, what we can do to confirm this suggestion? So what simply we can do, we got the voltage and current for RA, then we will get the voltage, replace this RA by RB and find voltage and current, and then replace this by RC and find voltage and current. So we will change the resistance and measure the voltage and current. That's right. So we'll change the resistor and then we'll measure the voltage current to find resistance of each. In this question, complete the circuit diagram to show how a three resistors connected in parallel, a voltmeter to measure a potential across the resistor, and a variable resistor to control the current in all three resistors. So you can use a screen annotation to complete this. Three resistors in parallel, a voltmeter to measure the potential, and a variable resistor to control the current in all three, like to change the total current. So three resistors in parallel, and there should be a variable resistor as well because we want to change the total current. So before or after the combination, and the voltmeter in parallel to measure the voltage of each resistor. Because they are in parallel, So they will receive or they will have the same voltage across it. The circuit in figure 1.5 could be used to determine the combined resistance of three resistors connected in parallel. Suggest a reason for connecting a variable resistor in the circuit. So why we connect a variable resistor here? What is the reason for connecting a variable resistor? Even I will get one value of voltage and I'll get one value of current, and voltage divided by current, I'll get the resistance. But what is the reason why I connect a variable resistor here? No, resistance will not change. Voltage and current will change to get more values, because what happened, the voltage and current will change but the resistance will remain same. Like example, if first voltage was 10 and the current was 2, so 10 divided by 2, which is equals to 5 ohm. Then what we do, using a variable resistor, will change the voltage. Maybe the voltage will become 6 and the current here, or voltage become 5 example, and the current is 1 ampere, so 5 divided by 1, what we'll get 5 ohm. So resistance will not change. What we'll do, what is the effect of this variable resistor? So we can change the voltage and current in the circuit to get more values or more set of result, like set of voltage and current. So using a variable resistor, can repeat the experiment with different sets of voltage and current. Next question. A student is determining the focal length of a lens. Figure 2.1 shows the apparatus used. The student obtained a sharply focused image on the screen. On figure 2.1, measure the value V from lens to the screen. So what you have to do, because this is not a hard copy, the measurement will not be correct, but what you will do, you will just place a ruler or a scale next to this and measure the value of V. I'll just take an approximation. Example, the approximate value of the V is 6. On the figure, this is by measurement. So on the figure 2.1, 6 centimeter. It can be in millimeter as well. It's up to you what unit you have to use. Figure 2.1, measure a distance d from illuminated object to the screen. So from illuminated object to the screen, so what you will do, you will place a ruler and measure this distance. So example, that is 8 centimeter. Yeah, that is according to your value, like, but I'm taking the numbers, like this is 6 example and this one is 8. Now they mention figure 2.1 is drawn 1/10 of actual size. So this is the figure size. In a figure it is 6 centimeter. So what will be the calculate V, the actual distance from lens to the screen, and record in a first row of a table 2.1. So if figure it is 6 centimeter and figure size is 1/10 of actual size. So actually it will be 10 times more. So it will be 60 centimeter. And same thing for D also, calculate D. the actual distance from illuminated object to a screen and record in a, so D is the actual distance, so this will be 60 and the value of the D will be 80. Then calculate U multiply by V and record in the table. When I multiply U with V, 20 multiplied by 60, what is the answer? Twenty multiplied by 60. Yeah, it will be 1200, the product. So these are the values. So this was 60, 1200, and this was 80. State one difference that you expect to observe between the image form when the screen is, when U is 20 centimeter and U is 30 centimeter. Look, U is, what is U? U is the object distance and V is the image distance. If U and V are same, if the object distance and image distance are same, it means the size of image will be equal to size of object. But if U is smaller and V is larger, the side which is, because if a lens, example, this is a convex lens. So if object is placed closer to the lens, what will happen? Image will form away from the lens. Parallel light ray, it will pass through focus, one through optical center will pass straight. The point where the two light rays will converge, that is the image. So when object is closer to the lens, the image will be away from the lens. And here in this question, the distance, object distance is denoted by U and the image distance is denoted by V. So if U is greater than V or V is smaller, then the image will be small. If U is equal to V, then image will be same size as the object. And if U is less than V or V is larger or greater, then the image will be large. So in the question they are asking, as you work out the values of U and V, V was here 60 and D was 80 here. So when I compare the first value, U is smaller and V is larger. So it will be, image will be larger here in the first one. But the second one, U and V are approximately same, like 30 and 29.5. So what difference we will observe? In the first experiment, the image size will be larger. In the second experiment, the image size will be same as the object. So they will have a different size. Or even different brightness or intensity of a light for images. You can mention that as well. Use the result in the figure in the first row of a table to calculate f1, the focal length 1, U into V divided by D. The row 1, V was 60, this was 1280. So focal length 1 is U into V divided by D. What is the answer for row 1? That is coming out 15 centimeter. Focal length is a length, so that's why the unit should be same as like length. And all the measurements were in centimeter. That's why this is also in centimeter. Then calculate F2, which is U into V divided by D. So U into V divided by D. What the second value means? U into V is 885 divided by 59.5. What's the answer for the second value? 885 divided by 59.5. 14.9. So the first value was 15 centimeter and the second value is 14.9 centimeter. Now calculate the average. How to calculate the average? Just add them and divide it by 2. So 15 plus 14.9 and divided by 2. So the average will be 14.85. 895, sorry. Yeah, it was 14.9. So 14.95, but when you write your answer, you should write your answer into 3 significant figure. So you can round it off this to 2 to 3 significant figure, only your answers are accurate. So you can write the average as 15 here. Or 40, if you write 3, this will be 14.9. If you round it off to 2, then it will be 15. Then suggest 2 reasons why it may be difficult to obtain a reliable results in this experiment. In this experiment, what happened? The light is passing through a lens and we'll see the image on the screen. So what are the difficulties in this light experiment? Number 1, it is difficult to obtain the sharp image. Or difficult to see. Yeah, the image edges may not be clear or sharp. It's not a sharp image. Parallax error. And it might be difficult to measure center of the lens, or because as you can see in the picture, the first one, that it is difficult. What we are doing, we are doing all the measurement from the center of the lens, but as this lens is there, it will be difficult to exactly recognize where is the exact center of this lens. So this difficulty is there, or it is difficult to obtain a sharp image on the screen. These are difficulties related to this experiment. A student state that more reliable value of the focal length is obtained if more values of U and V are collected, enabling a graph to draw between UV against the D. Suggest a suitable number of value of U, like how many times we should measure different values of U, because in this experiment we only take 2 values. So whenever you are doing the experiment 5 times, 20 times is too much. So 5 times, 7 times, 6 times, it will be sufficient. So we can do this experiment or measure the value of U5. Suggest a suitable range. Look, how to identify the range? to identify the range, as you can see, we are using this lens experiment. Imaginary line which is passing through the center of the lens. That is called principal axis, and the distance between the principal axis and the focus, that is called focal length. And there is another point which is called 2f, which is double of the focus. So if focal length, as we know, we calculated focal length is 15 centimeter. So the range which I will use for you, like placing an object, I cannot place an object within the focal length, because if I place within the focal length or even on the focus, it will not be a sharp image. So the limitation is that I can only place the object after the focal length, and even beyond 2f or after 2f, but not too far away from 2f, otherwise the image will not be too blur or it will be diminished, we will not able to see. So what is the approximate range we can use? We cannot place the object within 15 centimeter. If I place an object within 15 centimeter, image will be a virtual image, and virtual image cannot be taken or cannot be seen on screen. So what I can select a range here, I can choose 15 centimeter to onward, like 15 onwards to, or you can write 16, you can mention till 50, till 40. Is it clear? Why not before 15? Why we did not write from 0 to 50? Because if it is like 14, the focal length is 15, so we'll not get a real image. The image will be virtual. A student is investigating whether the diameter of a pendulum bob affect the time period of a pendulum. The period is the time taken for one complete oscillation. Figure 3.1 shows a pendulum oscillate. Figure 3.2 shows one complete oscillation. The student has the following apparatus: a pendulum bob made from a polystyrene with a diameter 1, 2, 3, and so on. Plan an experiment to investigate whether the diameter of the bob affects the period. You should list additional apparatus that you require. Explain how you carry out this investigation. State the key variable that you will control. Draw a table with a column heading, and how would you use your result to reach the conclusion. So whenever there is a planning of experiment, what you will do, you will try to answer the question in terms of points. List the additional apparatus to measure the time period. What else I need here?
Stopwatch, clock.
Yeah, so we need a stopwatch here, because without using a stopwatch, and same thing, we want the a stopwatch, as well as why we need a meter rule here, because the length of, we want to keep the length of the pendulum same
Yeah.
for every time. So how we'll make sure that the length is same? So we have to measure. That's why the additional apparatus what we need here, we need a stopwatch and the meter rule. You can use meter rule along with the set square to avoid a parallax error. That's correct. Then explain briefly how would you carry out the investigation. Means they're asking for procedure, method. So how we will do this experiment, what we will do, we'll measure the length of a pendulum by using a meter rule. I will write this. So we'll measure the length of the pendulum by using a meter rule. Then we'll attach a bob, mark mean and extreme position, and record the time for 20 vibration. Then divide the time by number of vibration to get the time period. And then we'll repeat the experiment or repeat the procedure with different size of bobs. So measure the length, record, mark mean and extreme position, record time for 20 vibrations, divide time recorded by number of vibration, that will give us the time period, and then we'll repeat with different bobs. This metal sphere, this is known as a bob of this pendulum. Then state key variables, the things which we will control or we will keep constant or same. So what things will,
Length and time period.
yeah, the mass also should be same,
Mass.
because length of a pendulum, number of vibration which we do, they're asking for state key variable that is kept constant or same. So amplitude should be same, length of a pendulum, number of oscillation. Pendulum bob made up of, here when diameter is changing, the mass will also change, because as they mentioned, they're all made up of polystyrene. So mass we cannot control here, as the available bobs are made up of same material. If there were different materials and different size, then we can say the mass should be constant as well. So the key variable is the length of the pendulum, the original length, the amplitude, the displacement, the time interval, number of oscillation, not the time interval. Like we record the time for 20 vibration for all of them. Then draw a table with a column heading to show how you display your result. So how we will display our result? Because what we will do, we will have the time for 20 vibration, and then like this is say material bob size, which is in millimeter or centimeter, then time for 20 vibration and time for 1 vibration. Bob size we know, like we were having 2, 3, 4, 5. Time we did, because we did not measure, so even it's writing a bob size is not an important. The important thing is what table you will draw to show your result. Is it clear? I'll share another link with you to complete discussion.